This video is about plugging certain values into formulas and also solving different equations for a specified variable. So in our first example here, it's about wind chill. And wind chill temperature W in degrees Fahrenheit, produced by a 30-mile-per-hour wind at various air temperatures T, also in degrees Fahrenheit, can be modeled by the formula W equals 1.36 T minus 26. We want to complete the following table using the given formula. So the first row are the values of T, and we want to calculate the values of W that go along with those. So we're going to replace the T with a 15. And so again, I like to write out what I call the shell. So I'm going to write out this equation basically, and instead of a T, I'm going to put an empty set of parentheses. So that'd be W equals 1.36. And then instead of the T, I'm going to leave an empty set of parentheses, and then minus 26. And in the empty set of parentheses, I'm going to put the number that I'm replacing the T with, which is negative 15. And I'm going to bring up my calculator because we'll do these calculations on our calculators. So we're going to take 1.36 and multiply that by negative 15. So I have to, my calculator is a little bit weird, so I have to type in the 15 and then change the sign. And so then I get negative 20.4, and then I'm going to subtract 26. And we get negative 46.5. Do the same thing for 5, so that would be W is equal to 1.36 times 5 minus the 26. And so I left that empty set of parentheses where the T was in my original equation, and I'm replacing that with a 5 this time. So 1.36 times 5 equals 6.8, and we're going to subtract from that 26, giving us negative 19.2. And I'm going to change that back to black. And then plug 30 in. So again, I'm going to write out my shell. W is equal to 1.36 times an empty set of parentheses, and then minus 26. And we're replacing that T with 30 this time. So 1.36 times 30 gives us 40.8, and then from that we're going to subtract the 26, giving us 14.8. In the next example, we're going to use the same formula to determine the wind chill temperature if the air temperature is 70 degrees Fahrenheit. 7 degrees. And so again, we're just going to replace T with 7. So I'm going to write out my shell. W equals 1.36 times an empty parentheses, and then minus 26. And in the empty parentheses, we put what we want to plug in, which is 7. And now we're going to do that calculation on our calculators. And 1.36 times 7 gives us 9.52, and subtract from that 26, giving us negative 16.48. And that's in degrees Fahrenheit. The next one, on a cold day in New York City, the wind is blowing at 30 miles per hour. If the wind chill temperature is reported to be negative 18 degrees Fahrenheit, then what is the air temperature on that day? Use the formula W equals 1.36 T minus 26 to solve this. So right now, this negative 18 degrees Fahrenheit that they gave us is actually the wind chill temperature. And so now instead of replacing the T, we're going to replace the W in the equation with what they've given us. So we'll have negative 18 is equal to 1.36t minus 26. And so now we want to solve this equation for t. So I'm going to add 26 to both sides. So we have negative 18 plus 26. That gives me 8 equals 1.36t. And then we're going to divide by 1.36. And that gives me 5.88. And this is also in degrees Fahrenheit. So now in the next problem, we want to solve the formula for the wind chill for T and redo problem 2. So 2b. So we're going to redo this problem after we solve this equation for T. So we have W equals 1.36T minus 26. And to solve this for T, so we want to isolate the T. So I have to get rid of the 26. And excuse me, this is minus 26, so to undo that, we're going to add 26 to both sides. So now over on the left, we have W plus 26, and it's equal to 1.36t. And then to finish getting t alone, we just need to undo that multiplication of the 1.36, which means to divide by the 1.36. And so we get the equation t is equal to W plus 26 divided by 1.36. So we want to redo this problem. We want to figure out what the temperature of the air is if the wind chill temperature is negative 18 degrees. So we're going to plug a negative 18 into our equation for W here. So negative 18 plus 26 divided by 1.36. And again, we'll end up with 8 divided by 1.36, and we will come up with the same answer that we got before, 5.88 degrees Fahrenheit. Oops. And this one didn't say to round, so just be careful if it tells you to round to a specified number of decimal places, and it should tell you on My Math Lab, it should be very specific about how they want you to enter your answer in there. So if it said to give this answer to the nearest degree, then you would want to answer 6 degrees Fahrenheit, because you would round this 5 up to a 6 if they wanted it to the nearest degree. In the next problem, if the wind speed is 15 miles per hour, the wind chill temperature W can be approximated by the formula W equals 1.28T minus 19, where T is the air temperature in degrees Fahrenheit. We want to solve this for T. So we're going to do the same thing that we just did with the other wind chill formula. W equals 1.28T minus 19. We want to solve this for t, so we're going to add 19 to both sides. That will give me W plus 19 equals 1.28t. And the last step then would be to undo this multiplication by dividing by the 1.28. And that gives us the formula t is equal to W plus 19 over 1.28. Now we want to use this new formula from part A to determine the air temperature, T, if the wind chill temperature is negative 10. So we're going to replace the W in the equation we just found by negative 10. So that'll be negative 10 plus 19 divided by 1.28. And negative 10 plus 19 is 9, so we get 9 divided by 1.28. and that gives us 7.03 degrees Fahrenheit. Again, if you want to round that to the nearest degree, you would answer 7 degrees Fahrenheit. Again, this isn't telling me to round to anything, and so I did it out to 2 decimal places. Our next problem talks about a weather balloon. It has, so it's launched, it starts out at sea level, and the balloon is carrying instruments that measure temperature during the balloon's trip. After the balloon is released, the data collected shows that the temperature dropped 0.0117 degrees Fahrenheit for each meter that the balloon rose. If the temperature at sea level is 50 degrees Fahrenheit, determine the temperature at a height of 600 meters above sea level. So the starting temperature is 50, and it decreased by this much for each meter that it rose. And so if it rose a total of 600 meters, the way that we would calculate how much the temperature dropped is we would take the number of meters and multiply it by the drop for each meter. So that would be minus 0.0117 times 600. Okay, so this will be the drop in temperature for the rise of 600 meters. So you can just type that right into your calculator. 50 minus 0.0117 times 600. And your calculator will automatically do order of operations. So we get 42.98. Write a verbal rule to determine the temperature at a given height above sea level on a 50-degree day. And so what we're going to do is we're going to subtract 0.0117 times the number of meters the balloon rises from 50. So that's our verbal rule telling us what we're going to do. If T represents the temperature in degrees Fahrenheit, a height of m meters above sea level, translate the verbal rule from part B into a symbolic rule. Okay, so T is going to be what we're calculating here, and that's going to be equal to 50 minus the 0.0117 times m. Okay, so this is how much, so it's going to go down this much for each meter that it rose, and m is the number of meters that the balloon rose above sea level. So this would be our equation. And now we want to use that equation to complete the table. So we're going to plug 500 in, so that T equals 50 minus 0.0117 and then times the 500. And again, we can just do that calculation right on our calculators. So 50 minus 0.0117 times 500. And we get 44.15. And then do the same thing, but plug 750 in. T is equal to 50 minus 0.0117, and then times 750. So that'll be 50 minus 0.0117 times 750. and we get 41.225. And now do the same thing for 1,000. T is equal to 50 minus 0.0117 times 1,000. Plug that into our calculators. We get 50 minus 0.0117 times 1,000, and we get 38.3. Solve the formula T equals 50 minus 0.011 m for m. So we want to get this m by itself. So the first thing that I need to do is move this 50 over to the other side. So we're going to subtract 50 from both sides. That gives us t minus 50 equals negative 0.0117 m. And then we're going to divide both sides by negative 0.0117. Okay. Water freezes at 32 degrees Fahrenheit. We want to determine how high above sea level, or the height above sea level at which water will freeze on a 50-degree day, and we're going to use this formula for m. So we want to calculate the height, or the number of meters above sea level, that it would take to freeze water. So we're going to replace the T with the temperature that water freezes at, 32. That'll be 32, and then minus 50. And then we're going to divide by negative 0.0117. So we have 32 minus 50. That gives us negative 18. And we're dividing that by negative 0.0117. And so hit divide by, and 0.0117, and then I need to change its sign, and then hit equals. And so we get 1,538. So in order for water to freeze, you would have to be at 1,538 meters above sea level. Temperature to what degree? Average normal body temperature for humans is given to be 98.6 degrees Fahrenheit. A body temperature of 100 or above usually indicates a fever. A patient in a hospital had a temperature of 39 degrees Celsius. Did she have a fever? So here's the formula, and so this is really to convert Celsius to, or Fahrenheit to Celsius. And so we're given the Celsius and we need to figure out Fahrenheit. So we're going to plug this 39 in for Celsius. So that would be 39 equals 5/9 times the quantity F minus 32. So we want to divide both sides by 5/9. And again, we're going to do this on our calculators. So 39, and then divided by, and then just make sure that you put that 5/9 in parentheses. and that's 70.2. So then these 5/9 cancel, and we're left with, what was that, 70.2 equals f minus 32, and so the last step would be to add the 32 to both sides. And so we get a temperature of 102 degrees Fahrenheit, 102.2. And so the answer is yes, she did have a fever. Now we want to take that equation to convert from Fahrenheit to Celsius, and we want to solve it for F. So we're going to do the same thing that we did in the last problem. We're going to divide both sides by 5/9. And so when you divide by a fraction, you really multiply by its reciprocal. So over on the left-hand side, then we'll have 9/5 C is equal to F minus 32, and then we have to add 32 to both sides. So we get the equation F is equal to 9/5 C plus 32. Now in the next couple of examples, we're going to be solving them for the indicated variable. And this is the formula for a rectangle. A equals LW. We want to solve it for W. So we want to get this W alone, so I have to divide both sides by L, giving us the equation A, or W equals A divided by L. In the next one, we have P equals C plus M. We want to solve it for M. And so that means I have to subtract C from both sides, and we get M is equal to P minus C. In the next one, we have the perimeter formula for a rectangle. P equals 2L plus 2W. We want to solve this for L. So we want to get this L alone. I'm going to subtract the 2W from both sides. That gives us P minus 2W equals 2L. And then to finish getting the L alone, we're going to divide both sides by 2. That gives us the formula L equals P minus 2W, all of that being divided by 2. In our next one, we have R is equal to 165 minus 0.75a, and we want to solve this for a. So we need to get this thing alone, which means I need to move this 165 over. So I'm going to subtract 165 from both sides. That gives me R minus 165 equals, now remember this is negative 0.75a. And then to finish getting the a by itself, we need to divide both sides by negative 0.75. So a is equal to R minus 165 over negative 0.75. And our last example, v is equal to pi r squared h, and we want to solve it for h. So all of this on the right-hand side is multiplication, so all we need to do is divide by the pi r squared on both sides. So that gives us the formula h is equal to v divided by pi r squared. And that finishes up our lecture. Let me know if you have any questions.